Welcome everybody. Today I would like to simulate a VAR. I would like to simulate a vector autoregressive process. I would like to generate some impulse response functions. It is an introduction, so I think that the example is chosen to be relatively simple. So how does a reduced VAR look like? In equation 1, we have GDP on the left-hand side of the equation. So this is the growth rate of GDP. And then on the right-hand side, like there is an intercept. And also the lagged growth rate of GDP plays a role, as well as a lagged inflation rate. Furthermore, the whole process is disturbed by an error term, like this epsilon is related to the GDP equation. Simultaneously, we would like to estimate also the second part of this equation, like the inflation rate in period t also depends on a constant, the intercept, and then the lagged growth rate of GDP, GDP growth rate of the previous period, and then also the lagged endogenous variable, so the lagged inflation rate of t minus 1. Furthermore, there is also an error term in this equation, so the whole process is also influenced by this mu. It is a reduced vector autoregression. Therefore, GDP in period t does not depend on the contemporaneous inflation rate in period t, and also the inflation process in period t does not depend on GDP in period t. This is different in a so-called structural vector autoregression. There, it might be the case that in equation 3, GDP in period t is also influenced by the inflation rate of the same period, or it might be the case that the inflation rate in period t is influenced by the growth rate of GDP in period t. We are not talking about structural vector autoregressions today. We are talking about this reduced vector autoregression. I would like to assume that only one GDP shock occurs in period t. So in period t, epsilon takes the value of 1. So we normalize the error term to the size of 1. This will, of course, directly have an impact on the growth rate of GDP, because in period t, you can see here that GDP in period t will react and will be up by 1 unit. How does this situation look like in the next period in t plus 1? There, it will be the case that GDP in period t plus 1 will be influenced by the initial shock, but also like we have a spillover effect from the first part of this equation to the second part of the equation, because now inflation will also react to the lagged GDP shock. This is mentioned on the next slide. So in period t plus 1, GDP in t plus 1 is up by G11 units. G11 units because it is G11 times the shock of period t, but we normalize the shock to the level of 1, and therefore GDP in period t plus 1 will be up by G11. In case that G11 is smaller than 1, then the shock will be digested to some extent. What about inflation? In period t plus 1, the inflation rate in t plus 1 is up by G21 times the GDP shock of period t, which was normalized to 1. So the inflation rate will be up by G21 units. What about period t plus 2? This is interesting because now the GDP in period t plus 1 will in period t plus 2 will be influenced by the lagged endogenous variable. GDP in T+1, but also the inflation rate of the previous period. Same is true for the inflation process. So in period T+2, GDP in T+2 is affected by its own lag and additionally by the inflation in period T+1. And therefore, it might be the case that GDP in period T+2 might even increase despite the fact that the parameter G11 is smaller than 1. What about inflation? In period T+2, inflation is affected by its own lag and additionally by the GDP growth rate in period T+1. So now I would like to come up with a numerical example. We will assume that the two intercepts are equal to 0. We also assume in our simulations that GDP in period T will be affected 0.8 times by the GDP in the previous period. So this parameter G11 was assumed to be equal to 0.8. Then G12 is assumed to be 0.2. In the second part of this system of equation, we assume that G22 is equal to 0.5. So like an inflation shock is to 50% like reduced after one period, and this G21 parameter should be equal to 0.3. So this is the assignment question now. You should simulate impulse response functions in Excel. In scenario A, we are looking at this GDP shock. We assume that the economy is in equilibrium in T-3, T-2, and T-1, so that both variables, GDP and inflation, take the value of 0. And then we assume that a single GDP shock occurs in period T, which takes the value of 1. We should simulate the time series of GDP and inflation for the next 10 periods. We should plot the impulse response functions for the two time series. And later on, we want to work in EViews. And EViews would call these time series like response of inflation to GDP innovation, like to a GDP shock, and response of GDP to GDP innovations, so a GDP shock. And therefore, you are also asked to use these labels in Excel. So I'll switch now to Excel. It is the case that we have in column C, like the time index from T-3, T-2, T-1 to like T+10. In column D, we are simulating the GDP series, and in column E, we are simulating the inflation series. In this part of the Excel file, like we have the beginning of the time series, so like GDP and inflation are in an equilibrium, so the values are equal to 0. In the upper part, you can see the coefficients which stem like from the numerical example. Now we have to assume that a shock occurs in period T, and it is a GDP shock, but there is no inflation shock at all. And now in cell number D10, like we have to create a formula, and the formula is as follows. We have to refer to the coefficient of 0.8. We are freezing this cell by pressing the F4 button, so we are putting a $sign in front of D, a $sign in front of 3, and we are multiplying through by the GDP of the previous period. Then we are adding the next parameter. We are also freezing it, putting a $sign in front of D, $sign in front of 4 by pressing the F4 button, and we are relating it to like the inflation rate of the previous period. When I press OK now, the value in cell number D10 should be equal to 0.8 because the GDP shock will to some extent be digested, and the inflation rate in period T is equal to 0. So cell number E9 does not influence this result. So this is indeed equal to 0.8. Next one, like we have to also initialize the process for the inflation rate. It is like 0.5 frozen times the inflation rate in the previous period plus like 0.3 frozen times the GDP in the previous period. So when I press this button, it should be the case that the value is equal to like 0.3. Inflation rate in period T was equal to 0. Therefore, E9, cell number E9, does not influence the result, but it is the case that the lagged GDP shock will influence inflation in period T plus 1, and it should be an 0.3. So now we can copy this information all the way down, and we are done. Now we can start to plot this time series. So let's use a time graph. I'll go to Einfügen, Insert, and I insert like a time graph like this one. And we also want to put like the right label to this time series. And the right label is the response of GDP like to GDP innovations. Like we have the shock in period T of the size 1 normalized to 1. And in the next period, it is a case that the shock is digested to some extent. So GDP in period T plus 1 will be equal to 0.8. And then the process will converge to 0 again, back to an equilibrium. Next one. Next picture, this is like the picture for the inflation rate. I'm marking this area and then I'm inserting the inflation rate. This is a response of the inflation rate to GDP innovations. And what is interesting here is that there is no shock in period T because the shock in period T only affects like GDP and not the inflation rate. Inflation rate is 0 in period T. But then in period T plus 1, the inflation increases to the value of 0.3. And it is a case that in period T plus 2 and T plus 3, the inflation rate increases. This is interesting because we have an increase of inflation rate over time, and only after period T plus 3, it will be the case that the inflation rate will decrease. Of course, we are done with part A, scenario A. What will be the next part? Next part will be that we are looking at one inflation shock. But GDP shock is analyzed here. So thank you very much for watching this video. Have a nice day. Bye bye.